said we're gonna do that, that exercise that was in a video?
Yep.
Sweet.
And you're going to be team captain. Hello there, sir.
Hi, how are you?
Fine, how about yourself?
Living the dream.
Oh, I knew I was in somebody's nightmare. Just because you're going to, oh, I thought you were going to hide out in the back there.
Don't let my students sit in the back. Why should I sit in the back?
Why do your students want to sit in the back?
They really can't because I'm in a U shape.
You don't have a back.
And that mango smoothie sure looks good.
Don't they though? That's mean what Ayano did there. That's just pure mean.
We're trying to decide which one of us is going to get this mango smoothie.
I want the strawberry one.
Yeah, we haven't quite decided yet. You caught us in the act.
Mike said that was mean just to put him there and let us look at him. I don't think it was mean. I think it was very mean. Go ahead, drink it. Let's watch you drink it.
Oh,
Go ahead.
Tell us how good it is.
Go ahead. Don't let us bother you. Yeah, go ahead.
I'm gonna enjoy it later.
Later when we're not looking.
Yep.
That's not gonna happen.
Teaching.
Don't look at the smoothies, Jordan.
I like that one.
She said one was for her and one was for you.
Hey, yeah.
Mike's not looking at him. There we go. I thought they were banana and watermelon. Shows what I don't know about smoothies. Of course, you're never really sure till you taste it. So I don't know.
Yeah, but we don't have any tasting, so.
Well, sure does look that way, doesn't it?
Nobody's sharing.
I know. Mike, would you bring something to class that you weren't willing to share? That's,
No, I wouldn't.
no, I don't think so.
I brought enough coffee for everybody.
Yeah, right. That's normal behavior.
I didn't know you guys love smoothies.
It's the colors, they're just so bright. They're
They're
delicious.
delicious,
Right. You know, coordinate with the.
Yeah, there you go.
You know?
So we don't want you to drink them, because then we can't look at the colors, so you can have them sit there.
So, can I put my stuff in here? I mean.
Yeah, it's available, just a second, let me do what I have to do. Yes, ma'am.
Thank you.
She's going, mine. Or I'll just block her off, you guys go.
I put a password on mine and I made it, capital.
Yeah.
Like, my password is all caps, so when I hold the, if my caps lock was still on and I held the shift, and then I typed in my password to try and get it, it wouldn't go. I freaked out for a minute.
Scary moment,
Yeah,
huh?
I was like, no.
I don't know how to bypass that password, actually.
I don't know if it would be a way.
I was interested, if you don't mind sharing.
Nobody in here minds sharing. That's who we are. Everybody's into sharing. No, I don't mind sharing. Who could mind sharing, possibly?
Invoice of a job you completed. And I was just curious.
If I pay taxes.
No. Nothing that, nothing that personal.
Did you clear it up?
Nothing that personal. 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 Nothing many hours did you put in to make this database for them?
Okay, I spent about 3 months on it, and I'd say about 3 hours a day. So 3 months is 12 weeks, times 7, say 300 hours.
Divided by 15,000 equal.
The other way around, dude.
Yeah,
Who'd you
well, I
think
knew what
that
I was
was?
talking about.
I knew about what you were talking.
Not bad.
Now, let me tell you about my other venture. Times were tough, and I underbid a project just so I could get it.
Good plan.
So I finished it, I got paid, and I did the division you just made, 9 cents an hour.
I'm starting to cry.
Been there and done
Ouch.
it, Mike, yeah. Well, times are tough. I
Like
see.
your shirt. Oh, thank you.
It matches her mango.
Oh, it does. That's cute.
Didn't you guys notice the shirt? You just noticed the.
And the one she brought for
Yeah,
Shoko.
got a watermelon and green banana
Yeah,
shirt.
her shake kind of matches your shirt too.
Yeah,
A little bit.
yeah. Well, you've been noticed enough today, I think.
Yeah.
Did you get those at
I
the
guess.
gym? Did you get those at the gym?
Yeah.
So good.
You get yours at the gym too? You guys got budgets over my budget, that's for sure. I get mine at a vending machine. You join it, Mike makes his own, you know, from scratch, grows his own plastic cups. Those things are no good when they warm up, are they? No, they're not so.
But he's cold, yeah.
Oh, yeah, we got something for you to look at.
Yeah.
Yes, sir.
How many gigs is it? Found this one at the DX for like $5, 16 gigs and waterproof.
Does it got a encryptor on it?
Don't know.
Password?
No password.
Yeah, they had 64 gigs for 15 clearance, so I put a bunch of them, more than I need. Do you remember when 1 gig came out, Jordan? Like this. The first USBs, 100 megabytes.
Remember when I was a little kid trying to get on the AOL internet and it was making all kinds of racket, dialing.
I used to like make the sound when it was dialing up
Yeah.
because I was so poor.
Me
I was
too.
just like mimicking it.
You were poor. Did you get those little cards that you put into?
I don't think we had a card. It was like I think it was a CD that you had.
Oh yeah.
That you had to run with it.
Like Netscape Navigator too. It's
Yeah, did you have the phone modems? Those are the best. 300 bytes a second or something.
Oh my god.
Yeah. It's actual phone.
The computer we had was huge though. Just the monitor itself was like.
Yeah, but as hard as we're laughing now, in 20
Big old
years,
box.
they're gonna
We're
laugh
gonna be
just
laughing.
as hard at what you got right
Yeah.
now, hot stuff.
Everything's gonna be like multiple terabytes.
I bet Shoko doesn't come today, actually. Sarah, did you miss some sleep last night?
Always. Always. Yep.
So 2 minutes and we will commence. All right. I've got an if statement on the board. Anybody wants to use themselves reading it? Trying to highlight the difference between and or. So the ands grouped together, separated by ors. Jeff is bouncing off the walls in the computer lab, screaming obscenities about access, switchboards.
That was me last night.
He lost his switchboard. It's irretrievable.
How did you do that?
He doesn't really know, but I did it myself when I was on that project. So I know his emotions. They are irretrievable. The solution is you take a blank database, build a new switchboard, then import all your tables and reports from the old database.
You just copy and paste them, or do you?
He has a natural import feature, I think. Actually, if anybody wants to get serious about access, I've still got 5 or 6 very thick textbooks for teaching, self-teaching. Okay, clock says we start, so we'll do that. Quite a few empty seats, unfortunate. The first thing I want to do is pass out your blank test. So if we're engaged in extraneous activities, could I get you to cease and desist and join the class? So this will be your blank test. The real test will be next class, which will be a Tuesday. And as you indicators on chapters 5 through 8 here. Hi, good evening, Shoko. How are you tonight? Good evening, Jeff. How are you tonight?
Even better.
Oh, don't tell me you got the database back. This time you got a switchboard, you got it back?
I had to import the entire thing, like the new one. That's what he said.
Well, same as I did 13 years ago. Exactly the same thing. Okay, join class. Okay, talk later. Now, this is your blank test. Mike, this is your blank test. Take your real test on Tuesday. So, Monday. Hi. Okay, now, so Kazuda, can you look at that later? Thanks. Now, what I've got on the board is an illustration of the difference between and or. So I'm going to read it to you. And it does occur in the form of an if statement, although you've been sheltered because you think you've been using Microsoft Access, but you haven't been using Microsoft Access at all. Microsoft Access is really what's called a jet engine, which executes the database. It looks after and executes the database. But running the jet engine requires a programming language called SQL. It's the only thing the jet engine understands are these program instructions. But Bill Gates doesn't think we should have to learn those. So he gives you a user interface, a shell, a GUI. So all you've been doing so long is building SQL statements. You click icons, you type, and Microsoft Access will build the SQL statement and pass it into the jet engine for execution. So you've been using nothing but a user interface. That's all Microsoft Access is. The jet engine basically hasn't changed since 1995. It does all the processing. So we will confirm to you that the SQL statements are being formed. And one of them looks like this. They often look like if statements. And SQL is the language of databases. Structured query language. Structured query language is a very high level language, 5th generation. And it's the language that databases operate by, the standard language. It's an easy language to learn. So all of your directions to Microsoft Access are translated into SQL statements by Microsoft Access and fed into the database. So this is be an example of an SQL statement. If today is a weekday, and they will pick that up from your criteria on the query, agreed? You list it. And the time is greater than 6 a.m., and down day equals no. So you see you have 3 ands. If those are true, then we're going to get up. In your case, you're going to select the record. Or, the next possibility, or today is Saturday and time greater than 10 a.m. and honey-do list is not equal to null. Then get up. Or today is Sunday and time is greater than noon and there's a good sports game on. Then get up. So you see how each one of your lines in the query has 3 criteria that are joined together. Now, if any one of these is false, for example, if the time is only 4 a.m., then none of this gets done. Now, if the honey-do list is null, equals null, then this doesn't get done, agreed? And if no game, then this doesn't get done, agreed? So any one of those and conditions is sufficient to turn off that entire line. That's what and means. However, just because this line is turned off, this line could still be turned on. And if any one of them is turned on, then you get up. These happen to be mutually exclusive because of the days that you chose, but there could be overlap. So I wanted to clarify the use of and with or.
Crystal clear.
I thought it was. How's your smoothie, ladies? Shoko, you had a question? A question, ma'am?
I know, I have a question.
Yes, ma'am.
What is the boundary?
What is who?
Boundary?
Oh, down day is when the base is closed for training. The base is down. The commander decides that this is a down day, no activities except absolutely critical ones will take place. It's a military term. It usually happens on Super Bowl days
Very important.
and other such events. Yes, sir.
They are now called and
Oh, PC.
I see there was a little bit of controversy about that. Training days, down days, family days, and all you single guys can go out and start your families.
They start your days. Or practice.
Big practice.
Good question, Ayano.
Infantry.
Okay, now the next order of business is going to be private keys, public keys. Now smile if you finished watching the video. You never smiled yet. Next time, first time. Now last time we watched the video up to a certain point. And at the particular point that we stopped watching it, I had given you a example, a rough example, no details, of how private key encryption worked. And we chose that key 65, we encrypted it, and then at the other end we decrypted it. So when I turn the video back on, and we will play a little bit more right now, I'm going to lead you through an exact, detailed, step-by-step creation of a private key and public key pair. and we're going to actually use them. It'll take about 17 minutes. And as it says in the video, when we finish, then I'm going to divide this class into two teams. One is the sending team, and you guys will have to create the message that you're going to send. I require it to be at least 10 words. You're going to have to create
10 characters.
we'll work on that.
It's 10 words.
Where I don't wanna make this too difficult for some people. Okay, don't wanna exceed your abilities at all, so we'll work on that. And then I would like that sending team to select a 2-digit key. We say 2 digits are too simple. We wanna keep it simple, a 2-digit key. And then they're going to encrypt the message, and then they're going to use numbers supplied to them by the receiving team. The receiving team is going to create two numbers. They're going to create the public modulus and the public exponent. They're going to create those. And their method of creation will remain secret to them. And the sending team is going to take those two numbers, and it's going to raise the key, the private key, to the exponent, public exponent, and then it's going to modulate it with a public modulus, and that's going to become the encrypted key. And they send that encrypted key and the encrypted message to the receiving team. And the receiving team decrypts with a secret number that only the receiving team has in the whole world. It reverses the encryption of the key by steps that will be illustrated here. And once it reverses the encryption of the key, it has the real key. And it uses that real key to decrypt the encrypted message. And then everyone shouts, "We win, we win," we get smoothies.
Wow.
So at the conclusion of these 17 minutes or so, I'm going to designate half the class to be in the sending team and half the class to be in the receiving team. But you don't know yet which half you're going to be in. So you're going to have to watch both methodologies. So let's commence and begin. So this take will begin about 1 minute overlap with what it did last time, and then it will go into new stuff. Ready to go?
Watch the rest where they did it earlier.
Hit it.
No, not yet. Light on. I'll let you know. I have those. So your encrypted key is known to be 2790. And you send it out. 2790. So this is what you broadcast.
How's the sound, Jake?
Broadcast your encoded message, and the key is 2790. So it's about a 1 minute overlap.
And you notice that how you got to 2790 was by this equation. But can he work that equation backwards? It's a modulus equation. It has no backwards. So he can't go backwards. So the only thing he can do is try to guess your key one number at a time and see if it fits this equation. Which he can do in 30, 40 years with a very fast computer. So you're not worried about that. Because in actuality, your key is 50 digits long. And because your key is 50 digits long, then by sheer guessing, he cannot guess it in a practical amount of time. The only thing he can do is reverse his equation, but modulus equations are irreversible. So he loses. Now, the only thing left is how does your good guy win? Because your good guy has a magic number. He has this magic number. T equals 2753. I'm going to show you in a couple of minutes how he created that magic number. But because he is the only person in the universe that has this number, he is the only person that can work that equation backwards. If you don't have this number, you can't work that equation backwards. If you do have this number, you can work that equation backwards. So this is a secret number, very private. Everything on this side of the line stays home. Let's see what happens if he takes the key that you sent him, which was 2790, raises it to his private exponent, 2753, and then one more time takes the modulus of 3233. Well, that's a fairly large power. Let's see if this computer can handle it. Try it again. 2790. And I'm going to take it to the power of 2753. And see if we can multiply it. And it did multiply it. Notice the exponent. It's only 10 to the 9,485th power. So good luck for the bad guy trying to count up possibilities, true? We're not worried about that. But now let's look at the magic that happens if I take a modulus 3233. Modulus 3233. Bingo. And the magic. Original key recovered, true? And untouchable by the bad guys. So the original key is recovered, and the bad guy couldn't have done it without this magic number key. So with the original key in place, I can change this back to violet. So the key 65 has been transferred to the receiver. Key 65 has been taken to a public exponent, is modulated by the public modulus, which creates an encrypted key. The encrypted key is transmitted safely because it cannot be reversed even if intercepted. When it arrives back to the person who originally created the public parameters, he has a magic number. And this magic number is capable of reversing that equation and pulling back the original key. So now I'm going to work through one example with simple numbers, showing all the steps in the order in which they actually happen. But I'm going to sit down, and you guys are going to create your own public exponent, public modulus. You're going to create your own message. This is our white face. And you're going to create your own key. You're going to encrypt your key. You're going to send it out, and you're going to decrypt it. So what you're going to do in 5 minutes is everything that I'm going to do now with an example. Now, the first thing to know is that this public modulus, which is the first number that goes public, was not picked out of the air. It is not any random number. It was chosen in the following way. To choose your public modulus, you pick two prime numbers, P and Q, and you multiply them together. And that gives you your public modulus. It's a product of two prime numbers. Now let's remind ourselves, what are the prime numbers? 1, 3, 5, 7, 11. Those are numbers that can only be divided by themselves as 1. 1, agreed? So now let's continue your expertise. Class, what's the next prime number? 13. Next. A different person.
28. Oh, 19.
Okay, those are all the prime numbers left less than 30, agreed? So from that list, I'm going to pick a P and a Q. Okay. Now, this particular public modulus that we used a moment ago was found by P is equal to 61 and Q was equal to 53. Those are the two prime numbers that were picked. And if you multiply those two together, then you will get the public modulus. But I'm going to pick some simpler numbers. And the two numbers I'm going to pick are that P is 23 and Q is 29. So all this is done prior to anything else happening. There's no published exponent, there's no published modulus. This is the first thing that's done, and the receiver does it at his own whimsy. He just picks two prime numbers. Now, in general, each one will be maybe 20 digits long. Very, very large. But still, there's tables of them, and I find it fun. So he picks two of these, and the public modulus is going to be the product of those two. So now, who wants to tell me? Calculators encouraged, perfect. One more time? That's right, 667. 667.
I think I had 100 to that.
So this is 667. So now that he's chosen his P and a Q, which he keeps very secret, he's the only one who knows the P and the Q. But the N, the public modulus, was not picked out of the air. It's formed as a product of two prime numbers. This is necessary for it to work. He picks the two prime numbers and keeps them secret, and now he forms this public modulus, which is 667, and releases it to the world. So when we say that this man creates a public key, it's a little bit misspeaking. What he creates are parameters that are used to create by the sender a public key, his own key. So this man shows the world the parameters that are to be used by anyone that wants to send a message to him. He doesn't create the key, they create the key. But he gives them the two parameters by which they will create the key. So the next thing he has to do is create his public exponent, which we call by the letter E. That's also done by very specific rules. Now we come to a very hard part of the calculation. Can someone please tell me what is E minus 1?
22.
You got this before? What is Q minus 1? So now what is P minus 1 times Q minus 1, Jose? Anybody?
22 times 28.
616. This is known as your private modulus. It also stays behind a wall. You do not show it to the world. Now you're about to create your E, which you're going to show to the world. Your E can be any number at all that does not have a common factor with 616. So you're free to choose that number, as long as it doesn't have a common factor with 616. So the easiest way to do it is to pick a low prime number, make sure it doesn't divide into 616. So I choose number 13. You can choose yours in a moment. Now, 13 is prime, agreed? So it doesn't have a cofactor. Now, the only thing is, does it have happy factors? The only thing is, does it itself divide into 616 evenly? Answer is no. So it's qualified to be our public exponent. So now that we have chosen our public exponent and public modulus, we're open for business. Anybody can now encrypt their keys. And this guy over here will do so. He will now encrypt his key according to the new public parameter. So it's a 65 to the 13th power modulus what?
667.
667. So this is his new encrypted key. Does anyone want to punch it in on the computer, or? This is a historic moment. Jose is using the computer the 13 on, no, start, okay, go, keep going, that's, well, that's one of our fairly small numbers again, really, and easy to work through. And modulus 667. 605. So this becomes the key that you now identify as your encrypted key and you send it back. 605. The bad guy looks at it. He knows that what you've done is you took your real key and you took it to the 13th power and you modulated 667 and you produced the 605. But that doesn't help him in the slightest to get your real key. It's impenetrable. Go backwards. This guy is going to get your real key if only he had his private exponent D. This is how he finds his private exponent D. This is why this public key algorithm took so many centuries to discover. It's not at all obvious how we should calculate his D. So now I'm going to share this with you. Sorry. You guys are now on the inside. You're now going to know how to get these private exponents. They come by the following prescription. D is equal to 1 plus K times the private modulus divided by the public exponent. Now you could say, where did that come from? Well, there's a little bit of math involved in where that came from. It's also not very hard to understand. But for the moment, we will just take that as being true. Now, the rules are that D has to be an integer. And the other rules are that K has to also be an integer. So that means D is equal to, which is an integer, 1 plus K. What's our private modulus? 16. This is also an integer. Divided by 13. So what we do is we make a table with all the possible values of K and the D's that they produce. 1 plus K, 616 over 13. Now, what's the maximum size of our table? It's going to be 12. Because if you continue to increase the number until it divides by 13, you only have to increase that number by 13 and it will divide. Because you're going to put a 13 into that number. So we only have to examine 12 Ks. There will be one of these. So let's take them one at a time. The first one is K will be equal to 1. So Jose, punch in 1 plus 616 and divide 13 and see what even. If it comes out even, we're done.
Divided by 13.
Yes. Tell me what you get.
48.38.
617 divided 13.
Is there 1 plus this?
1 plus 616 is 617.
Right.
Divided by 13. 13 is 47.46. So that didn't work because it didn't come out to be even. D will be the first integer we come to. Let's try 2. So what is 2 times 616 plus 1 divided 13?
2 plus 616 or 2 times?
2 times. 2 times 616 plus 1 divided 13.
And plus 1
Plus 1.
Plus the 1. So 2
times 6 ones
616
plus 1
plus 1.
divided by 13.
either. Let's try 3. 3 times 616 plus 1 divided 13. Okay, let's try 4. 4 times 616 plus 1 divided 13. Okay, now I'm going to let you take all the glory. You try 5 all by yourself. Bingo. We found our private exponent. It's the first integer that you arrive at in this table without a decimal point. So we have found 237. So we have found our private exponent, 237. And this is how we finish off. We take his encrypted key, 605, we raise it to our private exponent, and we take modulus 667 again, and we reproduce his original key. Try. 605 is encrypted exponent.
Exponent.
To the private, his encrypted key to the private exponent 237. Modulus 667, that's a pretty big number. Modulus 667. I wish I could say that I did this. But in truth, Wikipedia did this. Okay. So now, does the bad guy have any chance of recapturing the 65 without knowing these numbers? Without knowing P and Q, which gives him P minus 1, Q minus 1, which gives him the 616, which he needs in this equation. The only thing that he can do is take this public modulus and try to find 2 prime numbers that would multiply it. And this public modulus is 55 digits long. And if you try to work through all the possible prime numbers that could have been multiplied to produce it, then he's going to be passing it on to his great-great-great-grandchildren and still not having a time. So because this public modulus is so large, it cannot be found the 2 factors that created it, which are both prime. If he had these, he could do the rest himself. But he's never going to find the P and the Q because the numbers are so large. And because the numbers are prime, he can't bootstrap his way along by dividing by a 2 or a 3 or a 4, because none of those numbers will divide prime numbers. So he has to guess the prime numbers himself, and he never will. Sir, question?
So, being that those numbers are technically static, because they're selected at the beginning, I understand if he's only using one PC to attempt to crack this code, and let's just say he bots 1 million PCs to perform this calculation, he has a higher, greater chance.
That's right. That brings the time down to 93 years. So with our fastest supercomputers today, it's not at all possible to step your way through guessing, to do this by guessing, because of the sheer size of the numbers. And if our numbers were only of this sort, 2-digit numbers, then we could perhaps not guess our way through individually, but we could easily program a PC to break this by guessing all possibilities within an hour. No trouble doing that. But the numbers that we use in actuality are 10, 20, 30 times larger than the numbers used in the sample. So now what I'd like to do is to prepare you guys for your t-shirts saying, I am a public key practitioner, by having you develop your own public exponent and public modulus. And after you develop them, I want you to publish them. And after you publish them, I want the sender's team to pick up the published ones and to encrypt their key, which they will choose for themselves. And then I want them to publish their encrypted key for you to pull it back and to decrypt it using your D. Josh, this is your team. You guys are the receivers. Mitch, you guys are the senders. Now, what I want you guys over here to do is first, you're going to pick your own message. Not my message or Violet. And it must be at least 10 characters. And you can include spaces if you want, because we have spaces in here. Okay? Then I want you to pick your key. I chose 65. You can pick a 2 or a 3-digit key. And then you write it under your message. And then you go to the really hard part. You have to alphabet forward. Be sure you get agreement on this. And you produce your encrypted message, which you put in your visible set. Then you wait for your receiver to publish. There's public exponent and public modules. Once he publishes these, then according to this prescription, you encrypt your key and also make it public. After you do that, your part's done. Then they have to pick up your published encrypted key and put it into the reverse formalization, taking it to the D power, one more modularization, producing your original key, and then they will apply that in alphabet backwards to your encrypted message and tell you what you said. So you guys can start anytime you want. Jose is an adept calculator operator, so you need him. You start by picking your prime numbers, remember? Now, there's one thing to be sure that doesn't happen. The first one is 180.
Yeah, so,
Okay, so of course we need to have the alphabet. I can get some help on this. And then starts over. Now, I'm going to divide the class into senders and receivers. And these are the windows that we can operate in. I want that the sender will have a 10-word message or more. So 10 plus words. And the key should be just 2 digits. For the receiver, we want P to be between 30 and 50. This is a prime number. The Q also between 30 and 50, a different prime number. And we want E, your public exponent, to be between 10 and 20, a prime number nearby. So I will help either. So these are the teams, the way I formed the class. It parallels the teams that we had when we took the computers apart. So Jean, I wonder if you could join this window group. Now, Sierra insists that she be a leader of one of the teams, and I've acquiesced to that. So I would like this team, under the able direction of Sierra, to be the receiving team. And I would like this team under the, I'm going to pick Jordan H., although leadership's not important, work together, to be the sending team. So let's remind yourself, now are these compatible, or people really have a drive that they want to be on one of these other teams? Okay, we can do it twice and revert, no. So remind the senders, that's you. We need a 10+ word message.
10 words.
Yeah, you know what a word is. We'll start letters. It's got letters in it.
This can be loud. It's going to be 10 words.
Yeah, and now of course you're going to keep your word secret, your message secret. So this is your computer, and you can write anything you want on the back side, because that's where you guys create your actual message. And then on this side, the public side, you're going to show your encrypted message and your encrypted key to the world. Now you guys are going to have your computer also, and on your private side, you're going to keep your selected P and Q, agreed? And you're also going to keep your selected D that you worked through on the table. And on your public side, what are you going to show? E, the public exponent, and you're going to show your, what else? Public modulus, which is found by doing what? How is public modulus found?
P minus 1, Q minus 1.
That's your private modulus. Public modulus is found by
PQ.
PQ, thanks,
Sorry.
thanks. Okay, so let's go.
Boom.
Well, room,
All right, leader.
Oh my
You
god.
ready?
No.
you asked for this here,
Well, the first
I hope
part
it's
was
funny.
easy.
you asked for it.
Here's a list.
I am like math inept.
Pick two
Oh,
of those.
okay.
Between
I don't
30
know.
and 50, so,
We'll go with it.
yeah, any of these things.
13
We're off
is
to a good
number.
start.
I should say out loud.
But, you
this
know,
is-
there are better numbers.
These guys,
I just
these
was
guys,
saying.
these guys will listen.
I was just saying.
Even though you did say
No,
it
no,
out
no,
loud.
you can't just pick E. It
It's
has a
not
restriction
between
on
30
it.
and 50.
E cannot divide into your private modulus.
Or,
Yeah.
So you do E not first. First thing you do is find P and Q,
Right,
and you keep this,
yeah, so
pick P and Q, two prime numbers between.
between 30 and 50. So
Right.
13 already, you're killing it.
See, I'm never right.
I don't wanna see a message, because I wanna share the excitement of these guys' ability to decode it.
All right, so.
Are you guys the board?
Yeah.
All right.
You want me to our two-digit forward, or we want to
P
do
equals this.
two-digit key?
Oh, no, it's just small.
All right,
I
I'll
need
get
to
that.
change.
Two-digit key.
Yeah.
So, P equals,
There you go.
equals.
Okay.
Q.
It's weird this staggered pull.
Okay.
So now N equals.
Well, we don't figure that out yet.
And find that number. What is this?
Because we need,
Let them do
we
it.
need theirs before we pick our key.
Tell them not to.
Make it,
Oh,
It's public.
when they send us the thing,
You can shout
P
it.
times
they'll
Q.
plug into it, and we send that back to them.
Oh, I don't have a calculator.
Is it 1271?
Yes.
Okay, write it in the other side now.
Oh.
Okay, come over here,
Oh, about right.
come over here, erase all of this,
Alright.
and say N equals 1271.
Okay.
I'm spiraling.
Oh, I did it.
What a loser.
Alert, alert.
Everywhere.
So N equals 1271.
Correct. That's the public
Public
modulus.
modulus.
Two numbers, right?
Okay, now the next step is, you get the private modulus.
All right, so,
Yeah.
Let me get this math equation out.
right for that, not those numbers, just the P minus 1
Equals,
times Q minus
now P
1
minus 1 equals,
equals,
Q minus 1.
yeah, do that.
So we know what the
Now
public
multiply
mod
those
is
together.
now.
I followed the video.
Yes, isn't
Yeah.
that amazing? Isn't that amazing? What were you doing? You were writing something.
I was writing notes.
Well, that don't help you, you gotta understand. What good are notes
If
now?
I,
So now,
if I
this is
wrote it
1200.
down, I could
Okay,
reference it.
now you
later
get to
and
pick E, and Jeff can tell you how you pick E.
Yes, Jeff.
It's a prime number
Please
between
surprise
one
us.
and one.
Yeah, so I want,
It just, the only thing it must be prime and not
So
So we
divided
take our
into
key to the power of that
So now we have to do
mod
the
or
list
somewhere.
like this,
No,
right?
not yet.
The next thing is to pick two numbers and put the.
Yeah, I just don't remember if the numbers,
Well,
our key,
boom,
did you pick one?
yeah, right there.
Okay, what number did you
Just
pick?
pick two
Oh, is that,
numbers.
Yeah.
is this a public
any
number?
two numbers?
Any
Yeah.
two
No,
numbers.
it's a public number.
131.
No, it's written instructions.
Two numbers are.
And spaces, right?
Oh,
No, no,
that was a good number too.
It was a beautiful number, but it gives you something
10
to
and
speak.
20, all right, let's do,
So we are going with that.
Yeah, why not?
Good crime, right?
Yeah, there's about 4 of them. 11,
Aha.
13, 17.
let's try that one.
That's it. So E equals 19, publish that. Okay, we got you what you guys need.
All right. What are we, oh, we're receivers.
Yeah.
Now, you have to
Okay.
find your
Yeah,
private
easy one.
Stop, we're
modules.
done.
No, you have to find your private exponent.
Okay, so,
Now, this uses a complicated
all right,
equation.
remember
table.
this one? Write that. D equals 1 plus K times
Oh my
PM divided the whole
Okay.
thing by E.
Then we use the alphabet.
Times 1200.
And 1, 2, 3.
Yeah, and then
Divide
divide
by-
the
You have to
whole
explain
thing
this
by E.
process to me, so
Divided
that,
by this.
cause I'm lost right
Now,
after
you
this.
try different
So-
numbers
You
of K.
can't do
until
something,
it comes
so-
out even.
Right, this-
So, like,
this
remember
letter,
again, you just
find it
substitute,
on
so
there,
one
and then go back.
plus
Go-
one,
go
plus
forward.
1200 divided by
Yeah,
19.
alphabet
So
forward, 3,
start
4,
writing a
5,
list. This
6,
is
should
what
be-
K equals 1, K
Because
equals
it's done
2.
over there. They had the harder job.
They had the easier job.
No way. What does D and K and P and E
There you go, good call.
stand for?
Alright, so,
Tell me R,
so,
so I gotta keep looking back and
Yeah,
forth.
R,
What, I think it's,
divide.
So did one work, Jeff?
No.
Did two?
I need
Y,
longer,
9,
We can go all the way up to 18. We'll be somewhere less than 18.
yes.
So the first one that comes out
Because
even.
it'll never be-
is gold.
It'll never be enough.
Now, it depends on how pure you are, you'll get it right away, or near the end.
H, Q,
A,
So you don't need to write the numbers. If they have a decimal, it's wrong.
All right, I'm gonna work backwards.
Yeah, start at 18.
Okay.
Assume the worst.
Good call.
yeah. A,
Actually, you could program a little PC to do this in your life. That's how it's done. This is very manageable program.
yes.
God, we're gonna be ready to decrypt the message before we get a message to decrypt.
10 words, you guys,
Yeah, I mean, the alphabet's tough to work with, I
really,
understand that.
once you get it organized,
Yeah.
I,
you're in good hands, though.
Oscar,
6.
You know what? This is so easy.
It's very methodical.
It's a lot of steps, I think.
I can make a prediction.
Yeah.
3 down from B.
Yeah.
Actually, I'm one before you. I'm pretty deep. Maybe not.
All right, I'll try it.
A, low.
No.
No?
Space 9, no.
Oh, 9.
If you get a decimal, it's wrong. It's gotta come out even. So that's wrong, right?
No.
Okay.
Found it?
Hi.
What did you get? Not,
One.
yeah. No.
Yeah. Have you gotten that far yet?
Double check.
Have you gotten that? Okay.
No.
No. Sorry, God.
All right, I'm really good at math, you guys.
Clearly.
K-1200. K-1200.
Oh, sorry, no, no, yeah, yeah.
Oh, I'm doing it wrong.
Oh, okay.
K-1200.
It was this one or this one? Which one?
It's all gonna come out to be zeros.
Yeah, it
Oh,
was this
yeah.
And
C,
19
okay, we're
is
at 9,
zero.
okay. Yeah, it's getting a
Zero,
little.
an odd number?
No, it's not. It's,
E6.
it's this and then that, then divide.
Bravo. 9,
Right?
space.
I'm not doing that
You do.
order of operation wrong.
You just take this number and add one, and then multiply times this,
No,
and divide.
No,
no, order
it's-
of operations.
K-12, 1.
41, 31, CQ.
I did it wrong always, it makes me feel better. Because that's what I did.
Yankee.
Please excuse my ignorance.
Tim's got to be 10.
Wait a minute.
Because otherwise you're not gonna get.
W6, B
Minus
minus.
what?
Check 10 again.
Said
Speed.
space.
Yeah.
No, it's not 10.
Nope.
Fuck yeah.
You don't have to split it with your class.
How do you, wait,
Did you get this?
Okay, you
Okay,
guys,
so-
take a nap over there, do
This is-
something past the time.
So it's, right,
mhm.
parentheses. Then, then, yeah, I did that one. I did it the way you did
Oh.
too.
Okay, now
I
that
went the
one
whole way
stays
down,
home.
like one,
That
two,
stays
like, this
home.
is easy, like, how are these coming to whole numbers? This is
Nice work, team.
ridiculous.
Nice work. Now you just have to wait on a message to be sent you. You're open for business. Yeah.
This better be creative, because this is ridiculous.
Oh, it is a lot of, letters.
Now, after that, I don't know.
Okay, you guys got it encrypted?
Yeah, you're okay, we just give it to him now?
Well, we just, yeah, we can send it to him. Now, I don't think you wanna write it twice. Maybe you just
I
wanna
already
turn
wrote
the
it down.
board around, right?
No.
Give us a public.
Yeah, we can just give them
You
the,
just give it
paper.
this to him.
He wrote it down.
You don't wanna
Yeah,
tell them
okay,
what-
write it on the public side over here.
Right on that side.
Write it on this side. This is public over here. So you erase this side and write it.
So should we just erase this now and get rid of it?
No.
No.
Verify.
Take a picture.
That's protected now.
It's classified information.
Okay, you guys come over here, watch the action once it is.
Yeah. that's-
Read that to me.
That's
Is
J,
this one?
G,
Because-
F,
I think so.
Q,
As long as I have all the.
J, M, F, J, F, U,
Wow. Oh, I'm sorry.
O, B, Z, U, K, B, R, J, S, K, F, O, R, N, K,
Well, even I know what that is.
L, K, B,
You're a teacher, you know everything.
B, Y, K,
Except how to straighten you out.
B, B, Q,
BBQ.
and then O, B, K, B, G, A, F, A, T, X, B.
Okay, now write your encrypted key.
Yeah, give us all your public.
You encrypted your key, didn't you?
Oh, yeah.
Well, what's the encryption? Not the real key, but the encryption.
We didn't get that far.
You what?
So we gotta take,
That took me the whole time to come up with a word?
so we gotta take,
Your real key, which is between,
Yeah.
okay,
which
yeah,
is two
so
digits.
do that 13, or not,
Not 13? Why would I use that?
Nice
number?
move, Jordan.
All right,
Nice
13
move.
then.
Shiny.
So you take it to the power of the, public exponent,
Which
which is
is-
published?
Is
19.
19.
No,
Yeah.
public
19.
exponent. So you
It
take
is.
your key
19, looks like
19
So that's-
Your key to this power, modulus that.
break out your calculator and do it?
Oh,
No,
yeah.
you don't, well, if you want.
So their key, 19. I don't know.
Somebody shouldn't have said something.
It's not
Okay,
common.
so,
Well, I think it,
just, I
I
wanna make
just
sure.
had my note says that what they were using on
Think
the
it's
videos.
this.
So.
Which one?
the first
Oh,
one,
okay.
before I just remember he.
This is your.
Like this?
Yeah. And then.
Okay, so
Well,
it's, no, it's to the
Yes.
E power. You got it backwards.
Oh,
Yeah,
yeah.
that's what I was thinking too.
What
Yeah, it's
else?
backwards.
Yeah, that's what I
Can you
pictured.
check?
It's a, yeah, it's an E.
There we go.
Yeah.
Let's do it like that.
Oh,
So then
okay.
that'll give us our.
No, no,
Now
no.
that's not right, because it's like a 3-digit number here,
Modulus.
but the.
Oh, here, right? These
Probably
two.
one of the
Oh.
secondary ones.
Yeah.
Yeah, yeah,
This.
this times this.
Yeah.
The,
So this one.
yeah.
I had it up on my computer, my calculator.
Yeah, I don't have them on. Verify you do, I can't see it.
What's that?
We're doing, we got
Do
our
our
for
key
there.
for 19th hour.
Oh, okay.
But so
But
far, it's
just
that
in
modulus thing,
case.
so we think it's this. 'Cause he's-
Mod 1271.
So we're trying to find this number.
Alrighty.
Okay.
it's blank
Yep.
to the
Okay, publish
19
it.
Uh-huh.
mod
Encrypted
20
key
1271, right? Mod 1271?
Okay,
Yeah.
Oh,
mod 12.
one.
you guys can go to work now. This is their encrypted key. And now you guys have to use what you know to use your calculated numbers to find out what their real key is.
634.
And remember how to do that.
64 is public key?
This is their public key, their published key 634. So you know what you do to, you take it to what power? You take it to,
19.
no, you take it to your D. You take it to your D power, your D power.
That's spyware.
And then you modulate it to your public
That's
module.
right, I remember that, yeah.
Okay.
And it comes up to some insane to the 10
And then
10 to the 8 billionth power thing.
Not that small.
Well,
Yeah.
that's
Now, you don't tell them what you find, because this has gotta work.
We gotta-
Think
Yeah,
this
I got
small?
it.
Okay.
Was, so, okay, now,
What's
don't
taking so
tell them
long?
that, you guys go hide, because now you're going to use that to decrypt their message with alphabet backwards. And you guys get to rest.
Alright.
Because if they got it wrong, it's gonna come out to be nonsense, right?
What?
So alphabet backwards,
Or we
using
did
that.
something wrong.
So you write it under each letter, they didn't give you much room, did they? I wish
Oh, we
they-
have it on paper.
Yeah, I wrote it down.
Okay, so now spread your key out under it.
Oh, now you have no room.
No, right at the top.
Oh, so whatever,
Just
whatever
mark
number
your
they
name
have
under it.
now is what they write under,
Yes,
Alright,
gotcha.
tell me.
just like you did in
Right,
order
right,
to
right.
code it. Well, you wrote it over, but it works
Right.
almost as well.
Here, I got an alphabet right
Oh,
here.
you wrote it under it,
Yeah, but you went around the alphabet.
so they're gonna reverse it.
Oh.
They're gonna go alphabet backwards. you want
Italian,
alphabet
right?
forward.
Here, you need a pen?
No.
Have fun with that.
Hey,
Actually, usually you get a few words and they might be able to,
or
Figure out what it is.
yeah, except that you guys don't.
G?
We don't know.
I write it like weird.
Yeah.
Yes. So you're gonna throw them off, that was good.
Oh my god, are you
That's
serious?
gonna throw them right off.
oh, if this is H.
Have you already guessed it, right?
Yep. Space. All the F's are space. H. A.
All of the F's are space.
Space.
She knows it.
That's
Right,
not
all the
true.
way.
Okay, now, because you guys wanna sing it to him?
No.
What?
They
Oh, I messed
forgot
up.
a word, they muffed it up.
Oh, they did.
Yeah, they did.
Oh, okay, because I was like, this
Wait
is
a
a
minute,
space
that's
here.
definitely.
Where's the other
Come on,
space?
let's sing it, guys. Mary had a little lamb. Okay, so nice work on both sides.
Wow.
They got it.
Mary can't spell.
They found the 69, they worked it backwards, they got it.
Oh, that's yours.
Good work, team.
But that was awkward
Yeah,
when we found
that's-
69.
Oh.
538, come back.
That was good. Oh,
Let's do another one.
yeah, let's do another one. I'll let you figure it. Oh, you did, that's right.
Pat in the back all around.
Yeah.
Oh, careful on the camera there.
Oh, sorry.
I'm gonna slip these in the corner.
Oh.
You want me to move the other one too?
Yeah, carefully, please, into the corner here.
Yeah.
Thank you. He's the ones that take pictures for his parents, but what's the, no, come out. Out. Carefully. Okay, I didn't know you wanted pictures, so we'll bring them back out.
Oh, I already stars.
Oh, that's a.
He wants his own, he don't care about yours. He wants the work he did.
Oh, the E. What was the number?
It's like it was 19 for us, but how, if you just pick the number,
It had to be a number that
here's that 12, this number, I multiply, no, sorry. Here's the 1200.
Oh, it's like a, is it?
Yeah, so this number, and this can be divisible by this equal. So it's by 19, 1200 divided by 19, wasn't a number. If it was a whole number, I couldn't use it.
Jeff, you wanna put something on my computer?
Oh, hey.
Yeah, go ahead, go ahead.
Download
Go ahead,
some more.
Jeff, sure, yeah.
Thanks.
Thanks for checking. I'll take care of that.
You can say no and I don't do it, right? That's cool.
What?